Hello, everyone. All right, we are in Unit 8, Stoichiometry, and the last lesson we had was a conceptual one. It's not this one. A conceptual one where we kind of drew out the pictures, and hopefully we understood that the balanced equation is different than your starting amount, so you have to distinguish between the two. Let me autofocus this. There we go. So this is like your recipe, and then what the problem gives you is kind of like what's in your cupboard, and you're not going to use up everything in your cupboard if you don't have it in the same ratio as your balanced equation. Okay, so what determines then how much product you're going to make? Well, the reactant that you run out first is going to stop the reaction because you don't have it anymore. If you run out of it, you can't make any more product. So your limiting reactant is the one that's going to determine how much product you're going to make. All right, so hopefully we understood that from the worksheet that we did kind of together. And then I had you do an activity at home using baking soda and vinegar. And you saw how, depending on how much of each reactant you have, either one of the reactants could be the limiting reactant. So you can't just say, because I have more of this, it's going to be the limiting reactant. It depends on how the reactants react with each other, the ratio of it. Okay, so what I'm going to show you today is how to solve limiting reactant problems on paper. Okay, so to solve a limiting reactant problem, okay, you gotta, because it's still stoichiometry, you have to start with a balanced equation. So the first thing you got to do is balance the equation if it's not balanced already. Then what you're going to do is you're going to use those coefficients that you just figured out as mole ratios. So you're going to use a mole ratio to determine not how much product yet, because we don't know which one of the reactants we're going to use in our mole ratio to find the product, but you're going to use a mole ratio to determine which reactant will run out first, or run out. Okay, or will actually run out. Okay, and then that'll show you what the limiting reactant is. So we're not done with this yet. We're gonna just do this part for our first assignment. Okay, so this is in your Google Classroom. So all of these in limiting reactant practice problems one, you're going to just determine which one of these is the limiting reactant. We're not going to complete, this isn't really a complete stoichiometry problem, okay? So first step, you're going to balance the equation. So to balance this, I have 2 oxygens there. I need 2 oxygens here. That gives me 4 hydrogens here, so I got to put a 2 there. Okay, so this one can do in your head. Remember, if you can't do it in your head, put another piece of paper here and list, make inventory of everything and balance it with the tricks that I showed you. All right, the next thing you need to do is you need to convert your grams to moles. If they're giving you grams, then you can't put grams in here. Some of you did that in the quizzes, so you're going to need to redo the quizzes. I'll put new quizzes up soon. But you can't put grams in here because this is, the way these react is by the number of these particles, not how heavy they are. Okay, so you got to convert your grams to moles using molar mass. Okay, so we have 1.22 grams of O2. So we have to first convert that grams into moles using molar mass. And the molar mass of oxygen, 1 oxygen is 16, so 2 is 32. 32 grams is 1 mole. Okay, we're going to get our calculator. 1.22 divided by 32, and we get 0.038. 0.038 moles of O2. That goes here, 0.038. Okay, and then the other one is, other reactant is this, 1.05 grams of H2, and I need to also convert that to moles before we can put it in there. Remember the BCA chart is only for moles. Okay, and the molar mass of hydrogen, well, one hydrogen is 1.01, so 2 of them is 1.02. And then we take our 1.05 divided by 1.02, and we get 1.03. Let's round it. Okay, moles of H2. And I put that here, 1.03. All right, now what I'm going to do is, I'm going to do this in pencil in case I need to erase anything. Okay, so let's say right now, let's say it wasn't really obvious, excuse me, allergies, which one of these is the limiting reactant. Let's say I chose this one right here. So I'm saying, okay, my limiting reactant, this is the one I think is going to run out. Okay, and then the limiting reactant determines how much of everything else gets used up or made. So let's figure how much this would be. So if I did 1.03 moles of H2, okay, and I wanted to know what that was, I'm going to use my mole ratio. This is what I want, that's what I have, so it's going to be want over half, 1 over 2, so 102 over 2 H2s, okay, and I do my math, so it's going to be that divided by 2, it's already in my calculator, by 2, and I get 0.51. 0.51. Okay, now I'm going to look here and see, well, does that work? And as you can see, it doesn't work, because if I only had 0.038 moles of this stuff, there's no way I can use up that much. I don't have it. I don't have it. So this is not going to work. That's not the right, this is not the limiting reactant. I'm not going to run out of that. I'm going to run out of O2 before I run out of that amount. So, therefore, this is what I'm going to use up, all of the oxygen. And now I'm going to use the mole ratio here, using this as my starting amount to figure out how much hydrogen I actually used up. Okay, so this didn't work. So I'm going to start with 0.038 moles of O2 and use my mole ratio. This is what I want this time, so it's want over half. So 2 H2s over 1 O2. So I'm going to take that number and double it, 0.038 times 2, and I get 0.076 moles of H2. So I'm going to use up 0.076. Okay, and then also from this, I'm going to figure out how much of that I'm going to make, and it looks like it's that same ratio, so I can just do this. Okay, and obviously I start out with none, no product in the beginning, and I'm going to end up with that here, and then I'm going to subtract these two to figure out what excess I have. So 1.03 minus 1.03 minus 0.076, and I get 0.95. I'm going to round it there. Okay, now I didn't have to do all that. I did the whole thing for you, but what they were asking for is identify the limiting reactant. So the limiting reactant is the one that ran out. Which one ran out? Oxygen. So O2 is limiting. Alrighty. Okay. So to find the limiting reactant, you're going to do it like a test, like how I did in pencil. Do a test to see if you do have enough of the other reactant, that the other reactant is in excess. Okay, the limiting reactant is the one that will run out. And based on your ratios, you can check to see that this does actually run out, and you have excess of the other reactant. Okay? All right, so solving limiting reactant problems, you balance the equation first, then you use a mole ratio to determine which reactant will run out. Okay, and then I did the rest of it with that example as well. So what did we do next? Okay, you know what, I forgot in here, change grams to moles. That's if they give you the starting material in grams, right? You have to change grams into moles before using BCA chart. Okay, then once you've figured out what the limiting reactant is, limiting reactant, okay, then use limiting reactant amount with mole ratio to find product. And then normally the question will ask you to give the amount of product in grams. So then your last step would be to change moles to grams using molar mass, just like we did up there. Molar mass. Okay, so let's try one more really quick. Ooh, we're at 12 minutes. Probably not. Okay, so I will do a video on the first, walk you through the first problem of worksheet number 2. All right, good luck.